Alright, so I wasn't able to record me filling out the paper notes, so I figured what I would do is just open up your 8.1, 8.2 assignments and pretty much go through them and kind of take notes along the way and show you the work to the problems along the way. So here's 8.1, and we'll just see how many parts it takes to record the whole thing. So why are there two square roots for every possible real number? Well, because let's just remember what, for instance, the square root of 4 is saying. It's saying what number multiplied to itself twice, that's what a square root means, will give you 4. So that could be two things. You could have 2 squared, because that will give you 4. Or in other words, we could write it like this. We could say that 2 squared gives you 4. Or you could say that negative 2 squared gives you 4. So in other words, 2 squared becomes 4, or negative 2 squared becomes 4. So those are all the same thing. So in other words, how can you write 4? Well, 4, oh my goodness. 4 can be written as either negative 2 squared or 2 squared. So that's why there's two square rooted answers, because squaring a number or its additive inverse results in the same positive number. That's what they mean by additive inverse. Inverse means essentially opposite. So 2 and negative 2 are opposites because when you add them, you just get 0. Cool. All right, up next, well, let's start doing that. So what are the square roots of 25? Well, by the same idea, 5 or negative 5. Square roots of 49 are 7 and negative 7. And at this point, if we get more repeated questions like this, we'll just move on. Oh, never mind. If the index is even, what is the principal root of a number? Well, first of all, what do they mean by that? Well, when you have a square root, the idea is there is actually some invisible number here, n. All right, and so we'll put an x there. All right, so the idea is that n is what we call the index, and x, that stuff on the inside, is what we call the radicand, just so you know. So if the index is even, what is the principal root of a number? The principal root would be the non-negative root of a number. So in other words, what does that mean by example? Well, when you had, for instance, the square root of 25, we said that there were two answers, 5 or negative 5. But the principal root would be 5, the non-negative version of a number. And what they mean by that is, kind of like when we take square roots, sometimes we just say, oh, the square root of 25 is 5. Well, there are two answers, but usually we just automatically refer to the principal root of the number, the non-negative version. But there are two answers. That's kind of what leads to the confusion. Also, you kind of know that your calculator relies on just telling you the principal root. It doesn't tell you both. Why is an even root of any negative number a non-real number? Well, maybe let's say it like this. If I wanted to get negative 25 by multiplying, let me write it like this. If I wanted to get negative 25 by multiplying some number to itself twice, why is that not going to work? Because remember, multiplying some number to itself twice would look like that. And we know that if you were multiplying a negative to a negative, aka a negative something and its same negative something, you would get a positive. Or if you were multiplying a positive something and a positive something, you would get a positive. So as long as you're evenly multiplying something to itself, you should always get a positive number, because again, if they're both negative, you would get a positive. If they're both positive, you would get a positive. So there is no solution for that kind of problem. All right, so a negative number raised to an even power, where is it? A negative number, a real number, cannot be raised to an even power to get a negative value. That's the correct answer choice. So again, we can't raise any number to an even power and get a negative for all the reasons we just said. All right, well, let's see how that works itself out in a few problems. The principal root of 81 is 9. Oops, oh my gosh, I just keep clicking on everything. Well, the principal root of negative 9, or what is the square root of negative 9? Well, that's no real answer because, again, an even root, a square root, can't give me a negative. Counteract that with this example. This says the root of negative 9. Let me make this a little bit bigger if I can. Or negative root 9. Well, the thing is that negative is just going to follow along, and the root of 9 is 3. So notice the difference between this example and the one before it. If the negative's on the outside, you just carry it over, but if the negative is on the inside and it's an even root, now there is no solution. If you have a fraction, well, once again, that negative's on the outside, but if you have a fraction, then all you need to do is simply root each part of the fraction and put them back in their places accordingly. So the root of 64 is 8, and it was in the numerator, so 8 should be in the numerator. 49 roots to 7, and 49 was in the denominator, so 7 goes in the denominator. All right, then we get to cube roots, and so maybe let's talk about what the whole idea of like cube rooting or square rooting is. You know, square rooting has an invisible 2 in front as an index, but what does a cube root mean, or what are we trying to find with a cube root? I'll highlight this because we're going to have more like that. Well, a cube root of something means if I've got the cube root of 27, what I'm trying to do is I'm trying to say what number multiplies to itself 3 times to get me 27. And the answer just so happens to be 3. So that means 3 is just our final answer. The idea is if you can find some number that raises to the third power to get you 27, well then that third power and the root of 3 are just going to cancel out to give you 3. The other long way of getting around all this is simply, or rather the easy way of getting around all this long work of thinking about what number multiplies to itself 3 times to get 27 is simply to take out your wonderful calculator and type this in. Somewhere your calculator should have a like x root blank button, and typically you'll have to press like the shift button or the second button to access it. But wherever that number is, the way you would type this question in is you would first on your main calculator screen type 3, then you would press second or shift this button and then type 27 on the inside, and your calculator will just spit out 3, and that's fine. It can be hard to think of cube roots. We can kind of do squares, but cubing and anything beyond that is difficult. Now up next we have a cube root of a negative, and we might think that we can't cube root to get a negative, but it turns out that you can multiply a negative number to itself 3 times and get a negative. So the cube root of negative 8 is negative 2. If I multiply negative 2 to itself 3 times, I will get negative 8. All right, what about a fourth root of negative 1? Well, a even root can't produce a negative. So there we go. Now there's a negative on the outside, so the negative carries through, and the question is, what's the fourth root of 256? Again, that's a matter of just using your calculator, but I am pretty sure the answer is 4. Yay. All right, this one's a little bit tricky. Let me work that out over here. So there is a negative already. Oops. There is a negative already. And then I need to find the cube root of negative 1, which so happens to be negative 1, which will then double negate and just get me positive 1. So there was a negative on the outside, the cube root of negative 1 is negative 1, and then you will double negate and become positive. Up next, that same idea with fractions again. A cube root of a negative does have an answer. It will just have a negative included. 27 cube roots to 3, 125 cube roots to 5. Put them in their respective places on the fraction where they came from. All right. Up next, we get a very interesting idea here. If x is any real number, explain why this must be equal to absolute value x instead of x with no absolute value. Well, maybe let's try that by example. So let's say that I just had the square root of x squared. And let's say we assume that that equals x. All right, again, a square and a square root should cancel themselves out perfectly. Well, let's do something here. Let's plug in 5 for, or negative 5 actually, for x. If I do that, then in the first part here, here's what that would look like. Negative 5 plugged in for x. Well, when I plug in negative 5, first what's going to happen is I would square and get positive 25 because a negative times negative is a positive. and then the square root of 25 is just 5. All right? Well, the thing is, that was supposed to be just equal to x. So in other words, we assumed that this was a true statement. So this is giving me 5, but if I plug in -5 for x, the other side just says -5. So what I'm ultimately getting is an equation that says +5 equals -5, and that's definitely not true. And the thing that's going on here is because you're squaring, what's happening there is they're saying anything you plug in is going to become positive. Well, what does the absolute value symbol do? It says anything I plug in should become positive as well. Because without that square, this isn't guaranteed to be positive. So that's what the absolute values will end up doing. They'll force this answer to be positive. Okay, so the expression, I think that means it's C or D. The expression square root of x squared means the non-negative square root of x squared, even if x is negative. That sounds right. Yes. Now, how can we summarize this rule? I'm going to write it like this. If we evenly root a variable which results in an odd power, that variable must be wrapped in absolute value to be valid for all real numbers. Now the thing about that is there is going to be some extra stipulations on your questions, like for instance this one says assume the variable represents any real number. So now I need to be cautious of that rule. So let's work this out. Well, 121 just roots to 11, but the even root of x squared results in a single x. So I'm evenly rooting a variable, let me say it like this, if I evenly root a even exponent, or an even power, which results in an odd power. So that's what's happening. I evenly rooted, I square rooted, a even power of 2, which results in an even power, or an odd power of 1. Well then, that x needs to be wrapped in absolute value. And let me click that absolute value button right there. Alright, well this one is a little bit more complicated, but the idea is I'm once again evenly rooting an even power, which will result in an odd power, and since this represents any real number, I have to wrap still that entire expression, that entire rooted expression, in absolute values. Oops, I don't know what happened there. Alright, now this time, if I evenly root something to the 16th power, well, what's going to happen there is I'm actually just going to get to the 8th power. The thing is, a square root is essentially going to half the exponent that was there, because previously the exponent was 2 and it became 1 for all we've seen so far. So what's happening there is a square root is actually going to half that exponent. Now notice I'm not putting this in absolute value because when I evenly rooted this even power, what I got was another even power. So in other words, I know this result is always going to be non-negative, is always going to be positive, because that